Okay, so let's finish this off. And the last part of this acids and bases unit is a process called titration. And I'm going to try and do my best to give you a virtual lab for this because in the classroom, you should be happy you didn't have to do this. I'm kind of a stickler with the precision on this lab that you're supposed to have. And it makes for I guess it actually makes for some exciting drama. But anyway, here's what it is. Titration is a laboratory process in which a solution, acids and bases, well, in which a solution with a known concentration is used to find the concentration of an unknown solution. It's kind of why I was going to ad lib it because it's a confusing definition. But essentially, what we're going to do is we're going to take an acid or a base, but I'm going to say acid first. We're going to take an acid with a specific concentration to find out the concentration of a base because of what we just discussed in the last lesson, which was neutralization. So this formula, MAVA, is found in your reference table. Okay, it stands for the molarity of the acid times the volume of the acid will equal the molarity of the base times the volume of the base. And the reason that this works is because when you get something neutralized, not only is the molarity of the acid and the molarity of the base equal to one another, but really what you're actually calculating is the molarity or the concentration of OH minus being equal to H plus. That's what titration is really trying to find. How much base did it take to neutralize the acid? And by doing so, I would then be able to find out how much acid there is. So here are two examples, okay, math-based, all right? MAVA, MBVB. Mava is what we like to joke about. So here's an example. What concentration, M, how nice is that? It gives you that it wants molarity, big M. What is the concentration of a 200 milliliter NaOH solution would be needed to completely neutralize 300 milliliters of a 2.0 molar HCl? So as I normally do with you, you take all the stuff and you just identify what it is. 2 molar HCl, this is the molarity of the acid because HCl is the acid. If I had 300 milliliters of that 2 molar HCl, this is the volume of the acid. 200 milliliters of NaOH obviously is the volume of the base. And what am I looking for? MB. Now you have everything. So you plug it into the formula. MAVA 2.0 times 300. This does not have to be written in liters. Is equal to MB, or for those of you that want to put X, you can put X, times 200 milliliters. Solve for X. So what is the concentration of the base? Before I go, I just want to reiterate what we're doing here. Okay, we have a 2 molar solution. That means we have 2.0 moles per liter of hydrogen acid ions. And I have 300 milliliters of that. Once I find out what's the MB, this is the amount of OH minus that was needed to make this a completely neutral pH of 7 solution. So, math goes like this. 2 times 300 is 600. Divide that 600 by 200, and I would find out that MB is equal to 3.0 molar of my NaOH solution. Okay, so back to what I said. Now it should be a lot simpler. If I had a 2 molar acid solution and 300 milliliters of it, I would have needed 200 milliliters of a 3 molar base solution to neutralize it. Last one, and then you'll be off practicing and doing some online labs. How many liters of a 4.0 molar HNO3 solution is needed to completely neutralize 3.0 liters of a 3.5 molar solution of KOH? Identify what we got. HNO3, that's my acid. So if I have 4.0 HNO3, that's my molarity of my acid. How many liters of that? Okay, volume of acid is needed to completely neutralize 3.0 volume of the base of a 3.5 molarity of the base solution. Sorry. If you do that, then it's just simple cross multiplying, dividing, or just simple algebra, really. I'm looking for the volume of the acid. I have the molarity of the acid as 4.0 times the volume of the acid, which I don't know, also known as X, times the molarity of the base, 3.5 molar, times 3 liters. You can do it in either milliliters or liters. Whatever's given is fine to do it. Just want to throw that out there. So what does it equal? All right, so let's do some mental math here. 3 times 3.5 is 9, 10.5. 10.5 equals 4.0 M times VA. So what's 4 divided by 10.5? 2.66. That's going to have to happen. 2.62. So the volume of the acid that was needed in this criteria was 2.625. So we'll just call it 2.63 liters. Again, what that means is I had 3.5 molar solution and I had 3 liters of it. That gives me a total number of base ions that I have. I had a 4 molar solution, so a stronger solution. And if I had a stronger solution, I'm going to need less to neutralize the weaker solution. And so that's why you see the liter quantity goes down. All right, so I hope you have fun with the little online lab that I'm going to give you. And I hope you have fun with your calculator. And yeah, you're going to try this out for a little while and then you'll do the lab. So enjoy it, I guess. Something like that.